Now that we are experienced with truth tables and you've had probably as much of them as you really want, you're like, nah, I don't need any more truth tables. What we're gonna do is we're gonna apply them a little bit in a couple situations. So the first thing that we're gonna do in section 3.4, we're gonna get started on, is we're going to say, okay, are there ways that statements that appear different can be what's called equivalent? Okay, so 3.4 is going to talk about what's called equivalent statements. So here's the definition of equivalent statements. So we're going to talk about what it means to be equivalent in general, which I'm going to do in just a moment. And then after that, there's going to be 3 specific situations that I'm going to tell you are equivalent. And we're going to use a shortcut of just knowing that these things are already equivalent. So what it means for 2 statements to be equivalent is this. 2 statements are equivalent. And the symbol in logic for equivalence is a double arrow, but it has like an equal sign instead of a single bar in here, like biconditional, it has a double bar, like an equal sign. So that's the symbol for equivalence that we're going to use for logic. 2 statements are equivalent if both have exactly the same truth values. What that means then is when you do the truth table, they have the exact same last column, the same number of trues and falses, the same order of trues and falses. Okay, that means they're equivalent. So the last column will be exactly the same in number of trues and falses and the order of the trues and falses. That's important. Okay, so if you still have 3 trues and 1 false for both, but they're in a different order, that means they're not equivalent. Okay, it has to be exactly the same. So here's what you're going to do for me. Okay, I'm going to give you a few moments to do this. I would like you to determine, okay, by using truth tables. So you're gonna have to do 2 truth tables, and I've made this fairly quick. Okay, there's no negations in this, so this should be fairly streamlined. Here's one I want to know: is this statement P and Q or R, is that equivalent to this statement right here? P and Q or P and R? So what you're going to do, in case you're wondering, what does the Perkster expect from me right here? What you're going to do with the next few minutes of silence is you're going to do a truth table for this right here. And then if you want to use the same truth table, or if you want to do another one, you're going to then do a truth table for that. And you're going to compare the columns. If they're exactly the same, that means they're equivalent. If they are different in any way, that means they're not equivalent. Just the last column. Just the last column, yes. It's gonna look all different before that. All right, so I'm going to get started. If you're still working, keep working. I'm not meaning to rush you. So first thing I'm going to do is I'm going to do the truth table for this. So it's basically, it'll take me 2 columns to do this. I need first a column for Q or R. So I'm going to do Q or R. And you have told me, so I remember that Q or R, the disjunction, the or is true when either one of them is true. So the first line is 2 trues, so good. True, false, that's good. False, true, that's good. The fourth line is 2 falses, so that's false. Fifth line, 2 trues, true, false, false or true, and then 2 falses. And then I'm going to connect statement P. So right here, I'm going to connect that with this using the AND statement. So P and Q or R. What I'm going to do is I'm going to do this column in blue to set it apart so that we can compare the proper columns at the end. So this and that, the and you've told me correctly many times, the and statement is true when both of them are true. So the first row is both true, so true. Second row, both true. Third row, both true. Fourth row, true, false, so that's false. Fifth row and sixth and seventh and eighth all start with a false, so the last 4 all have to be false. So what I have, according to my order of my statements, is the first 3 results are true, the last 5 results are false. So when I do the truth table for this, if my last column is the first 3 are true and the last 5 are false, then I will say that they are equivalent statements. Continuing then, I'm just going to continue to use this same truth table, but if you constructed a whole new separate truth table, that is fine as well. But here we go. So now I'm going to take care of my parentheses, P and Q. So here is P and Q. It's an and statement. And statements are true when both are true. So true and true, the first 2 are both true and true, true and true. And then the next ones all have a false as part of the statement. So since the other 6 all have a false as part of the statement, they're all false. P and R. So the same thing. It's an and statement. So the first row, true and true. The next one, true and false. The third one, true and true. Fourth one, true and false. And then finally, again, since P is false for each of the last 4, that tells me all of the last 4 are false. And we're finally to the finish line. Finally to the finish line. And so now I'm going to take this column right here and this column, and this time I'm combining them with the or statement, the disjunction. And so because it's the disjunction, only one of them has to be true for the statement to be true. So true or true, true or false, false or true. And then all the last ones are false, false. So that means the last ones are all false. So when I compare the 2 blue columns, when I compare this one right here and this one right here, are they identical in every way? Same order, same number of trues and falses. 3 trues, then 5 falses, 3 trues, 5 falses. They are identical in every way. So that means that these 2 statements that I gave you are indeed equivalent. Okay, so is this equivalent to this? The answer is a big yes with an exclamation point. Since we did all that work, we're going to be happy about it. I've got just one more problem one more thing we're going to do, okay? Because we'll come back. We're going to do a couple more problems like this, but what I've decided is I'm gonna type some stuff up so that you have less writing to do. So I'll take care of that, and when we come back Tuesday, we'll do a few more problems where we do truth tables to show if things are equivalent. But what I'm going to do is I'm going to introduce there's 3 equivalences we'll talk about in this section. We're going to talk about the first one and introduce that, and then I've got 2 examples, and then you'll be done. You can head into the weekend. You didn't get a break from me this week like the Monday and Wednesday classes did, so you deserve a little. So the first of the 3 specific equivalences, things that we can just know are going to be equivalent, and I'll show you that these 2 things are equivalent. The first one's called DeMorgan's law. Now, if that sounds familiar to you, maybe it does, maybe it doesn't. Depends on how much the homework you did for Unit A. There's a DeMorgan's law for sets, but I didn't really focus on it because it wasn't super useful. But for logic, it is very useful. And it has to do with what happens when I have a negation out in front of either an and or an or statement. This does not apply to conditional or biconditional. Okay, so don't generalize this in ways it's not intended. So if I have a negation out in front of a P and Q, or if I have a negation out in front of a P or Q. And what students always ask me every semester is, hey, professor, can I just distribute that negative? Because we're used to arithmetic where we can distribute negatives and everything's set. And the answer is sort of. And what we're going to do, one of our last 2 problems is we're going to show that one of these is equivalent using a truth table. It won't take as long as the last problem. But what you can do here is this. You can distribute the squiggly, but you have to remember one bit of trivia. So if I want to distribute the negation to squiggly P, and then I'm going to skip the sign for a minute and squiggly Q, that's great. That's not a great Q, but we can do the distributing, but here's what you have to remember. If there's an and in here, DeMorgan's law says that it has to become an or. Okay, so we have to flip the sign. Do you have to distribute it? There's some times when it's useful. So we're getting used to it. The same thing is true if you want to pull the squiggly out. Okay, if you want to pull the squiggly out and create an it is false statement, then you have to flip the sign. So this second one, following the pattern, if I'm going to distribute the squiggly in this second one, what do you think the sign is going to be in the middle of this second one? An and. Yeah, you got to flip the sign. Great. It's going to be a caret, an and. That's what DeMorgan's laws is. It's kind of a distributive property for the negation when you have either and or. Okay? Again, I'm just going to repeat this because this is a common mistake. This does not apply. You cannot distribute the squiggly if there is a conditional or a biconditional in the parentheses. It doesn't work like that, unfortunately. Right, it does work for disjunction and conjunction, or disjunction conjunction. All right, here's your second to last problem for the day. What I would like you to do, please, is let's just do the first one. I want you to show, using a truth table, I want you to show that squiggly P and Q is equivalent to squiggly P or squiggly Q. Okay, so you're just doing a truth table like we did for the previous problem that was much longer. You're going to use the truth table. You are demonstrating that DeMorgan's law is true by using the truth table. All right, so my two truth tables. Notice the nice thing about this problem is there's only two simple statements, so I only need to have the 4 combinations of trues and falses. There's no R statement, so I don't need all 8. So if you did all 8, I'm sorry, you did more work than I was intending. Okay, so, but I understand. So just be wary of that. When there's only 2 statements, you only need the 4 rows. First thing I'm going to do is the stuff on the left. I'm going to do P and Q. It's an and statement. And statements are true when both are true. So true and true, good. True and false, false, false and true, and then false and false. And then I'm going to put a squiggly in front of that. And a squiggly, as you've told me 50,000 times already, just changes the truth value. So this column right here, I'm just going to change all the truth values. So false, true, true, true. There we go. Now the other side of this. I need a squiggly P and I need a squiggly Q. Squiggly P, well, if P is 2 trues, 2 falses, squiggly P is going to be 2 falses, 2 trues. Squiggly Q, if Q is true, false, then squiggly Q is false, true, false, true. And then last but not least, what I'm going to do is I'm going to take those 2 columns and I'm going to combine them with an OR, with the disjunction. So I'm taking these 2 squiggly columns right here and I'm combining them with the disjunction. The disjunction's true when either one is true. So the first one's going to be false because there's no true there. The next one is true. The next one is true. The last one is true. And so once again, do I have the exact same last column? Is it the same in every way? Yes. So you did what I wanted. You showed, I told you these 2 things were equivalent. So the spoiler was, it should turn out to be great. And it did. So we did what we wanted. Excellent work, everybody. We are going to pause here. So we